Hello, my name is Pappy Bedard. I'm a retired engineer and a Cinema 4D hobbyist. Welcome to another one of my tutorials. The past few months I've been self-isolating without any internet, but I'm glad to be back. On one of my tutorials I got a question asking me how I would approach modeling a Mandel bulb. I didn't have the answer, but that made me start looking into fractals, and I ran across many videos on YouTube of the Mandelbrot Set zoom. That made me consider how would I do that in Cinema 4D. But instead of just assigning colors on a bitmap at each point on a plane based on the Mandelbrot set, I decided to try displacing points on a plane. Now, with any task in C4D, there are many ways to do it. This tutorial will show you one way. It's somewhat long again, so I'll divide it into sections and provide direct links to the sections in the description. I'll also provide links to the references I make in the tutorial, and I'll post the Python code so you can cut and paste it to save you some typing. So without further ado, let's get started. So here I am in Cinema 4D R21. And before we get into programming the Mandelbrot set, let me just cover some of the basics. So we'll create a plane, and I'm going to make it editable by typing C. And as you know, you can modify individual points manually here, or you can click on this structure menu. The structure menu shows a list of all the points, or you can go into polygons and it shows you which points make up each polygon. So I'm going to go back to points, and let's say I click on point 42. Well, that's right there. And just like you could manually change the Y value of the point in the interface, you could also double click on the value in this structure list and type in a value. So I'll set that back to 0. So obviously we're not going to want to manually change all these points. So we could do that programmatically. So what I will do is add a programming tag, an Xpresso. And in here, I'm going to drag the plane and expose its object tag. And I'm going to add a Python node to add a little bit of script. I'm going to delete these default ports. And I'm going to create a new one called link. A link lets you link an object into the Python node. I'm going to rename that port OBJ. Now when I click on that one and go back to the attributes, I can open the Python editor here, and it's got some default code in here, and we're just going to get rid of that. So what we want to do is modify point number 42. So let's start out by setting a variable number of points and make that equal to OBJ. That is the object that's linked. And what I want to do with that object is get the point count. So there's a function for that. So now NPT will be equal to the number of points on that plane. And so for every point in that range of points, I want to do something. I'll check to see if I is 42, Oops, I switched over to different language there for a second. So if I is 42, what I want to do is from that object get point I, which is 42. Well, I'm going to set a variable. So I got PT is now that point 42. All right. And what I'm going to do with that is set point I to a Cinema 4D vector with the same X as point X, with the Y of, say, 100, and the Z of the same point as the point Z. And close that parenthesis. So let's see if that works. Just going to close these windows. And I'm going to enable and disable that. All right, so that's pretty cool. Now let's say I want to make that user controllable. So let's go to this tag and create some user data. So we'll hit manage user data, click on here, add a group. We'll call that params for parameters. And then in that group, add some data, and we'll call this height. So the user can dynamically change the height, and we'll just make this a real number. And let's put no limits on it and default it to 0. So now we have this parameter height. Let's go back into our Xpresso rig here. And we're going to drag the tag in here. And we're going to drag height over to this little red square to expose that. On the Python node, we will create a new port. Well, let's make it a float, rename it to height. And link that height in there. And then in the Python code, we'll say here that h equals height. So that'll grab that value from that port. And then here, instead of 100, we'll put an h. And let's see what happens now. So if I go to here, now if I change the height, yeah, so I can dynamically change this. So that's how we can change one point. Well, let's make it a tiny bit more interesting. I'll go into the Python editor. Let's say instead of just point 42, I'll say if let's say mod 7 equals 0. That means if every 7th point, it's going to grab it. So if it's divisible exactly by 7, it'll grab the point. And let's see what that does. Go click on here. All right, so now every 7th point can be changed. All right, so that's basically the basics. Now, with a Mandelbrot set, what we need to do is set a distinct value for every point on this plane based on the formula that we're going to use for the Mandelbrot set. Now, here's a couple of tips. Change this to 0. And right now, this plane object is an absolute reference to this plane, which means I can't move that tag onto something else. It'll always reference this plane. That's because this is set to absolute reference. If instead I change it to relative reference, now it will affect the object that it's attached to. To demonstrate that, I will show you, I'll add a disk, and I will, let's say we'll make this more points on it. Change the radius. All right, I'm going to hide the plane, and now I'm going to move the tag onto the disk, and it will now, well, it won't affect it until I make it editable, but now it'll change the points on that disk. Now it's set to change every 7th one. I could move it back to the plane, and it'll work on the plane. Now, you don't necessarily have to have an editable object. And just hide those. So what I mean is, let's create a new plane, and we will, right now, if you click on the structure, you see there's no access to any points. But if I add a correction deformer, hold shift to put it as a child. Now if I click on the correction deformer and go to structure, now I have access to the points in that parametric object. So let's say I go to point 42 and I change the Y to 100. See, I can actually change the object even though it's parametric. I'll just set that back to 0, and just to demonstrate here, so if I go back to plane and change its segments, let's make it 15 by 15. So now there's more points on it. And going back to the correction deformer, now when you do that, remember it was 10 by 10? Oh, it's already updated. Okay. Sometimes you have to click on the correction deformer and do an update in order for it to remap to the new points. Keep that in mind if things don't seem to go well. So now we've made this tag a relative reference, so we should be able to move that onto the correction deformer, and here we go. We can modify the points on the, let's do this one more time. I'll set that back to 0. I'll change the plane to 22 by 22. So now we have still more points. I'll go back to the correction deformer, update it, click on the tag. So the only caution I would give you on doing this is once you start to get a lot of points, let's say we go 500 by 500 or 1,000 by 1,000, it'll take forever for the correction deformer to update itself. And I know that I tried 500 by 500 and it took a good 20 minutes for it to update itself. What it does, it actually loads all of the points in the parametric object into the Cinema 4D file. So the file gets a lot bigger. So anyways, for that reason, because it takes so much longer for the correction deformer to update itself, I'm going to stick with editable objects. Set that back to 0. And now, so obviously the reason it's a good thing is if we go back to this plane, it's not that easy to increase its resolution. One way you could do it is to select the plane and go into Mesh, Subdivide. So now it's got twice as many, and that should still work. So let's move the correction deformer up here. It still works. Now you might wonder, why aren't these points nicely divided like they were before? Well, there's a reason for that. It's because if I go into this plane and look at the structure, the points now have a different order. So right now, see, that's point 42 that's selected right there. Let's go to 43. It jumped from here down to here. Well, what is this middle point? I have to scroll down to find it. It's actually 192. So between 42 and 43 is 192. So it changed the order of the points when you subdivided. So that's one reason why if you wanted to know the exact location of those points, and that was important to the code you're writing, that would be something to keep in mind. When it comes to the Mandelbrot set, we're not going to use the point indexes, so those are irrelevant. We're going to use the x and z coordinates of each point to calculate the value. So that's the basics. Now, let's talk about the Mandelbrot set a little bit. The Mandelbrot set is a very interesting mathematical structure. Basically, it's a set of point values on a two-dimensional grid. The grid is basically the imaginary plane. Along the x direction, it's the real numbers, and along the y dimension, it's the imaginary numbers. So there's thousands of videos on YouTube. You could learn anything you want about the Mandelbrot set, so I'm not going to get too deep into it. But one great description of it is by this guy, Ben Sparks, on the Numberphile YouTube channel. I suggest you take a look at that and you'll really understand it. So the numbers on the 2D grid are the result of doing this calculation infinite amount of times for each point. C is each point you're looking at, and n starts with 0, so you square it, add the point you're trying to calculate, and then take the result of that, square that, add the original point again, square that, and so on and so forth forever. So here's a graphical representation of that. So there's 0, and here is the point that you're considering to see what the value is. So if you multiply this point in that, if you perform that z squared plus c formula onto that point, once you'll get this point, a second time you'll get that, a third you get that. If you do it an infinite number of times, eventually it winds up somewhere about there. So each one of these points in the black, you can iterate infinite amount of times, and it never leaves this radius 2. So if it never leaves the radius of 2, then we paint it black. But what if it eventually does exceed the radius 2? Well, that would be a point out here. You could see that you keep multiplying it. The first time it's here, second here, and so on and so forth. Eventually it gets past the radius of 2. That took a certain number of steps. Well, the number of steps it took to exceed the radius 2 is what determines the color or the value at this point. So what we have to do is take the grid of points on our plane, and for each one, we multiply it by itself forever. And if it exceeds the radius of 2, we make note of how many times that took. But now we can't really loop forever now, can we? Because the program would never end. So for these points inside the black, we define a cutoff point, the number of iterations we want to try. So if it exceeds that number of iterations, we stop and assume that it's infinite. And so those are the two values we have. One, if it's infinite, it's going to get this color. Another, if it's not infinite, but breaks out of that too, and then we use that number. So how are we going to do that and apply it to this? Well, I'm going to go ahead and clean up some of this. I'm going to delete the stuff we're not going to use. I'll create 3 new planes. And this one I'm going to make 80 by 80. This one I'm going to make 200 by 200. And this one I'm going to make 500 by 500. I'm just going to go ahead and rename them. Call this one 500. Call this one 200. And call this one 80. I'm going to make them all editable. And let's just test our code. See, this is the 80. That's the 200. And that's the 500. Okay, they all work. I'm going to reset that to 0. Reset that to 0. And reset that to 0. And I'll delete this plane. Okay. Whoops. Move this up here first, then delete this plane. Okay. And I think I will display just regular shading here because we have so many points. All right, so let's go back into our code. And we're going to change this. First thing we need is a function that will return the value of the Mandelbrot value, the number of times it takes before the number escapes past that radius 2. So I'm going to define, I'll call it get count. And we're going to have C, which is the point that we're accessing. So each point on the grid is going to be passed in as C. We're going to make a threshold. The threshold is going to be the value 2. That's the radius where we're going to decide whether or not the point multiplies past that radius. And we're going to create, let's see, we're going to have max steps. That's the number of iterations. The number of iterations for determining whether something is in or outside the Mandelbrot set. So we're going to use that z equals z squared plus c. So I'm going to have z, and I'm going to initialize that as a complex number 0, 0. I will now initialize the count to 1. And now we have to do a loop. So while the count, we have to do 2 things. The count, we're going to keep counting, in other words, multiplying z and adding c. We're going to keep doing that until either we exceed the threshold radius or we exceed the max steps. So the max steps is easy. So that's the count. So the count has to be less than max steps. And the other condition that will break out is where the rate. Now, how do you get a radius? Well, z is a complex number. It has a real and imaginary part. if you consider those two parts as two legs of a triangle, we need to calculate the hypotenuse to get the radius. So in other words, we have two parts of that. Z real is how you get to it, and Z imaginary. So Z real squared, add to that Z imaginary squared, and then take the square root of that. Now, to get square, and that has to be less than the threshold. Now, SQRT is a math function, so I need to import that from the math module. The way you can do that is to say from math import SQRT. So that'll give us that. Now, I'll put a colon there. So while those two things are true, keep doing this. Well, I just want Z to be equal to Z times Z plus C. That's that formula. And then increment the count. So it'll keep counting. Eventually, one of those two things in the while loop will be true, and it'll stop counting. At that point, we return the count. So that's the function we need to calculate each point. So now down here in our main, I have to clean up a couple things. I don't want the height to be hardwired, or the h to be hardwired to the height, because we're going to calculate a different h for each point. I don't need that if statement. And let's see. So we still want to get the point. And then we want to use for mathematical purposes, we're going to calculate x. We need an x and a y to create the C complex number. So in other words, we're going to eventually run this function. So let me plug that in here, and then I'll fill in the rest. So C is a complex number, but I'm just going to create one here. Complex takes two values, x and y. So x is the real part, y is the imaginary part. Threshold, well, we could just hardwire that to 2.0. That's the radius. And then max steps, well, we already have a variable called max steps that we're passing into right here. So now what do I need? I need to fill this in a little bit. I need to calculate x and y. So we'll start out with x is the x of that point, and y is actually it's the z of that point, right? Because we're working on an xz plane, but I want to convert it into x and y to pass to this formula. So x and y is the mathematical version of it, whereas point x and point y is the actual point values. And we want h to equal that result. So how many times does it loop? That h is going to be our height. But that's actually going to return a value between 0 and max steps, which is, depending on how we set max steps, we could have 400 or something. We don't want our height to be 400, so we want to scale that down. And the way we're going to do that is divide it by max steps. So that'll take all these values. Let's say it's 400. We divide it by, so that's going to give us values from 0 to 1. And then we'll multiply that times the height that we specify. So all of our values will be between 0 and the height we specify. Now I need to scale these things according to the values we input. So the way we're going to do that, all right, if you think about how this, let's push these aside for a second. Oh, I had gone into top view here. So this is the plane we're working with, and we know it goes from 0 to 100 on this side, 0 to minus 100 on this side. And we don't want it to be a big, huge canvas like that. We want to map this to a 2x2 canvas, or a 4x4 really, a radius of 2, so that a radius of 2 will fit perfectly in here. So I'm going to scale that by doing the following. I'll set a value S for size equal to the object, that's the plane. You can use getRad, which gets the radius of the bounding box. So it doesn't matter if it's actually circular or not. That's going to return a Cinema 4D vector with 3 components, X, Y, and Z. And one of those is going to be the radius. It could return 100 or 001. And so what I want to do is get the maximum of those 3 values of S. So the way I'll call it the canvas radius is going to equal to the max of something of 3 values. So I'm going to make a list in square brackets. S.x, S.y, S.z. So one of those 3 values is going to be the maximum, and that's going to be our canvas radius. So in our case, it's going to return 100 for that right now. And I want it to be mapped to, let's call it the Mandelbrot. I'll make that 2. So the ratio between the Mandelbrot and the canvas rad is 2 to 100. I'm going to call that the base scale. So that equals the Mandelbrot divided by the canvas rad. So think about what we have here. The canvas radius would be 100. And is it 100? No, I guess it's 400. Yeah, it's a 400, but it's a 400 plane. So the radius is 200 and the Mandelbrot is 2. So base scale is going to wind up being 1/100th. So all of the points we have on our plane are going to be divided by 100 in order to get the mathematical points we use to plug into that formula. So the scale, I'm going to modify the base scale by whatever scale we say to use. So if we put 1 in for scale, we're just going to get the base scale. But if we put 0.1, we want 1/10 of the base scale. So that's just the base scale times the Mandelbrot scale that we input. Again, that's one of our inputs right there. So now we have the scaling set. Now we need to modify the offset points of X and Y. Of course, when they're 0, they're 0. But we want to multiply times the scale and then add our offset. So multiply times scale and MPY. So that'll take care of our offsets. And let's see, what else do I need? I think that will do it. All right, if this doesn't work, I may have to do some debugging. I'm just going to push these off to the side on my other screen here. And okay, let's make the height 8. And let's say the max steps is 80. All right, I can see right now this turned yellow, which means I have some kind of a bug. So you can go into the console to the Python section and see what this says. I have an invalid syntax on line 20. Let's take a look at that. Aha, line 20, I forgot the equal sign. So yeah, I was going to do a little bit of debugging. All right, I'll push these off to the side again. And let's see if, well, I had it set to some values here. When I had paused the video, I was playing around with this. Well, let's set the scale back to 1 and the offset 0 and 0. So there is our Mandelbrot. I had also added a light so we can see it a little more clearly. Let's see what it looks like without the light. Still, that's okay. Now, we don't have very high resolution here for a couple of reasons. One, we're only using an 80 by 80 plane. And the other is that we don't have a lot of steps. We're only going 81 steps. Let me try 200 steps. That didn't make it look that much better. I'm going to turn off this plane. And let's go up. I'll turn off the 500. I'll put that on that one. Aha. So you see at a 200 by 200 plane, looks a little cleaner. Let's see what it looks like on the 500. Now this takes a little bit longer to calculate. There we go. So you see that the more points we use, the better resolution we have, but also the longer it takes. So just for purposes of debugging and whatnot, I'm going to stay on the 200 plane. So I'll turn this one off and turn this one on. And so let's play around with some values here. So I was trying to zoom into somewhere around that point. So I believe the offset in X could be 0.4. And the offset in Y, let's try 0.4. Now let's try zooming in to 0.1. Yeah, so we're a little bit off. So let's go X of 3.9. Actually, I can hold down the Alt key and click on this arrow to go down a tenth at a time. That's 2.9. That's too much. All right, so let's say 3.5. And let's go down a little bit more. So instead of 4.39. And now let's try zooming to 0.01. Okay, we're getting some detail here. Now, I had created this material. I'm going to start from scratch here. So we'll create a new material. And I'll turn off the transparency. And for the color texture, I'm going to use a gradient. And let's pick a preset. I like this one with all the colors. And instead of mapping it to 2D U, we're going to map it to 3D linear. Set these to 0. And we want the endpoint to be the same value on the Y as we picked for our height. So our height is 8, so I'll change that to an 8. And then we'll drop that on the plane. Now, something doesn't seem right. There doesn't seem to be enough variation in color here. Take a look at the perspective view. Yeah, it seems like all the points are either 0 or 8. There's nothing in between. So there's something wrong with the code. Let's go back in here. The height, oh, I see. Max steps is an integer, and this function returns an integer. So that's an integer, and it's getting multiplied by 8, so it's still an integer. So what I want to do is convert this to a float. So that we have a whole bunch of different values, not just integers. Let's see if that fixed it. Waiting for it to, here we go. Now we have a bunch of different values. Now it looks a little weird from this angle, but let's go back to the top view. And you're starting to see some of that cool detail. Just double check the color here. Interpolation is step. I'm going to change that to cubic bias just to smooth out the variation in color a little bit. That looks a little better. Let's try a slightly deeper zoom. 0.001. Yeah, so that's pretty cool. Go back to scale of 1. Set the x to minus 0.75 and y of 0. Here you can faintly see that 2-inch. That 2-inch that exactly fits our rectangle. Let me show you. If we go to a step of 5, there's our circle. So that's the simple version of the interface. Now, what would be nice is if this thing would automatically disable itself after each time we change things to speed up our interface. And here's another thing. So I'm going to go back to scale of 0.001. Well, you can see that here. Well, obviously, we're zooming in right in the middle, so you don't see anything. But let's say I put in 0.0000001. Well, it looks like 0. And if I click on it, it's still 0. But it's really not. Cinema 4D will remember all of the places you type. It just doesn't show it back to you. So I want to fix that little issue too. So we're going to build the next level of the user interface for this next. So let's take a look at this Xpresso. One of the cool things about a lot of the nodes in Expresso is they have this on button. You can turn it on or off. Basically, it disables or enables it. Sometimes it might be useful for us to, in fact, right now would be a good time. I'm going to disable it because it slows down the interface. Every time we do something on the interface, it has to run this code. And when you have a lot of steps or a lot of points on your plane, it becomes almost unusable. So it would be handy to be able to toggle that off and on once in a while so you could work on other things like camera movements and so on. So we need some variables. I need one to turn the Mandelbrot code off and on. Maybe one that'll turn the entire tag, enable it off and on. And I also want some character string fields that will show us what we actually type in for values here. Because like I said, if you put in a really small number like 0.10 zeros and a 1, like 1 trillionth, it just looks like 0 here. It'd be nice to see what we actually put in there. So I am going to click on this node and manage the user data. So we're going to add some more stuff here. Click on params. I'm going to add a separator. And we'll call this one switches. And under there, we'll put 2 switches. Say one called stay enabled. And I'll copy that one. Oh, wait a minute. Delete that. Stay enabled, and I want that to be a Boolean. True or false, on or off. And I'll copy that, and I'll make another one called Mandelbrot on. So that'll be used to turn this node off and on. And stay enabled will turn the tag off and on. Let's add another. Whoops. Click on switches. Another separator. We'll call this input data, where we can see the full text of whatever we type in. And we just need 3 string datas. So string, we'll call this one Mandelbrot X, and then we'll copy that, call it Y, and then we'll copy that. I'm holding control and dragging, and we'll call this scale. So we hit OK. Okay, so now we've got, I'll just look at the user data. So we have our input parameters, our switches, and our input data. So what I'm going to do now is grab this Xpresso and drop it again over here. You can have the same link, the same object more than once in the Xpresso, but this time we're going to input stuff to it. So let's see. I want stay enabled on this thing here to control whether this guy is enabled or not. So right here on the basic, we have an enabled property. I want stay enabled to affect that. And you'll see how that works in a minute. And then the other 3 ports we want are the Mandelbrot scale, the Mandelbrot X, and the Mandelbrot Y. So let's see, there's scale. I'll move enable to the bottom just to make this look a little better. So I want scale to connect to that, and MPX. Oops. We'll scale up. X, oh boy, and Y. And then we have another one called Mandelbrot on. That's going to be output here. I'll move that up in here somewhere. And that is going to attach to the on. You can drag and drop these to reposition them. So when Mandelbrot is on, that's going to be on. And when it's off, it's not off. All right, so let's see how that works right now. First of all, I'm going to hold shift down so I can see both of these tabs at the same time. So there's the enabled, there's stay enabled. Let me go back and change some of these scales. I'll change the scale to 1 and this to minus 0.75, and then I'll enable it. Let's hit stay enabled. Oh, my max steps is only 5. Let's make that 200. All right, I broke something here. Oh, Mandelbrot is not on. There we go. So if stay enabled is toggled off here and I enable it, it calculates and then it turns off, which is what I want. So I'll show you what I mean. If I make that 0.5, I enable it, it calculates, and then it turns off. So it makes it easier for us to go into the perspective view. Makes it easier for us to play around with values here. So, well, let's try a really tight zoom. Well, in order to get a good one here, let me go to my other screen here and see what I've got. I have this link, images from Mandelbrot. I'll provide all these links in the description or in a comment here. So some of these values are pretty small. Like this one you'd be able to see, but let's say, all right, let's look at this one here. So I can just copy and paste these. So the X is going to be this. The Y is going to be this. And the scale, I don't know if you knew you could do this, but you could actually punch in scientific notation just like that, 6.5 E minus 4. That actually works. So I'll put that in a scale. Now, that looks like 001, but it's really not. Let me enable this and we'll see what we got. So there's that spiral. Yep, same spot. Pretty cool. But these aren't actually showing what we typed in. So I'm going to tweak that a little bit. So there's a node in Xpresso that will allow us to show more decimal places than 3. I think it's actually called set decimals. Let's see, set decimals right here. So I'm going to drag that and we're going to plug the value into that and the result into that. And when I click on here, look at the node parameters. I'm just going to make that 20. And then we're going to Let's rearrange stuff here a little bit to make it easier to. All right, so I'm going to copy that twice. And the scale, the X is going to go into this one. And the Y is going to go into this one. Well, not the best arrangement of nodes here, but well, you get the point. You can kind of see what's going on. All right, now let's see what it looks like. If I change, enable it. Yeah, so now you can see the values we typed in. Now it does some rounding and stuff. That's just the nature of the way computers store data. But so if I typed in here 0.0000000001, that's pretty deep. Enable it. Well, the reason we don't see anything is we probably don't have enough steps. Let me back off a little bit. But you can see it looks like 0 here, but the actual scale is just what I typed in. So let me just go 1, 2, 3, 4, 1. Enable it. Okay, so see, that's where we're running into the limits of the number of steps we did. So just to show you how, let's say I increase the steps to 400 and then enable it. Now this is going to take a little bit longer to calculate, but there we are. We got a little bit more detail. Looks like we're a little off center here. So one of the things that would be nice to add to this user interface would be a way that we can easily point at an area and zoom in on that, or reposition to that point. And I think I will do that next. But yeah, let me just bring up that same let's try a different spot here. All right, how about this one? So paste that into the X. And then paste this into the Y. And paste that into the zoom or scale. And then enable it. Okay, we might be able to zoom a lot closer here. So right now we're at 0.00015. Let's go 6 zeros. 1, 2, 3, 4, 5, 6, 1. So that's 1/1,000,000th maybe. Enable it. Don't have enough steps. Let's try 5. 1, 2, 3, 4, 5. All right, now we're starting to see something. Let's try 4. Whoops. 1, 2, 3, 4, 1. Okay, so what I was doing is zooming in here, which doesn't really have any detail. So all of these are animatable, which is cool. You could create your own zooms. One of the way that people zoom in on Mandelbrots, which you see all over YouTube, is they use an exponential. So in other words, each second, it's a factor of 10 closer, or each time period it's a factor of 10 closer. So we can do that by tying the zoom scale directly to the timeline. And I can show you how to do that next. So what we're going to want to do is modify our Xpresso so that this M scale parameter gets changed over time by factors of 10. So we'll go into here and let's see, we'll create a time node, and eventually that's going to be piped into the M scale. So that's on this side. So whatever we do to this time is going to go into M scale, and then it's going to come out this side and pump it into our code. So I'm going to need a math node. By default, it's an add. So this is going into here, but we don't want it to be add. Actually, we don't want a math node. We want a formula node, I think. Yeah, this gives us a little bit more. So the value that's input, what are we going to do with that value? All right, we're going to use port name. Let's see, what is the port name? It's called value 1. I'm going to use port names and say, well, to raise something to a power, you can use POW. And it's the 10 to the value 1 power. So the way time works, it's seconds. So if you have 30 frames per second, then at 30 frames, the value is going to be 1. So 10 to the 1 power is 10. But if it was 0, at the 0 point in time, 10 to the 0 power is 1. So it's going to start out at the timeline at 1, and then each second it's going to go 1, 10, 100, 1,000, etc. But we don't want that big number. We want the inverse of that. So I'm going to divide that into 1. So 1 divided by all that, that's going to give us this new value, and I'm going to pump that into scale by connecting that. Okay. So let's see, at a relatively short, at a relatively small steps, we should be able to see this work almost in real time. So I'm just going to change this to 100 steps. And then here's where the stay enabled comes in handy. If I click on stay enabled, then each time it calculates, it's going to remain enabled and then go to the next frame. So I'll activate stay enabled and then enable it. So right away, that actually acted pretty quick. So now if I hit play, you see it's actually changing the value of M scale and zooming in on that point that we had identified. So I can actually jump ahead in the timeline, click anywhere, and you can see now that our number of steps is not quite enough to give us detail. But if I added a whole bunch more steps, well, then it would be a lot more difficult to use this in real time. But so I have a point in mind that I want to zoom in really close to, like 2.5 trillion times. I'm going to increase the timeline to 372. Double click here. I thought that's how you did that. Anyway, okay, so 372. So that's going to be a really high power of 10 when we get to the end. And let's see, I want to expand to full time. All right, so we can see the full timeline. Now I'm going to cut and paste some numbers here, and you can see what they are in a minute. So this is my scale. I'm going to turn off stay enabled for a second. That way I can work on this. This is my X. And this is my Y. Actually, I didn't have to paste in scale because that's going to be calculated by the timeline. It's really the X and Y I wanted. I'm going to enable this just to show you what the numbers are. Whoops. I'll enable it for a second here. Okay, so these are the numbers I just pasted in there. Pretty crazy numbers. All right, so let's see how this looks at various levels of zoom. I'm just going to click on the timeline. So I'm going to hit enable. So, and stay enabled, so this stays active. So I'll click on 120. It looks like I need a lot more steps. I'm going to actually go to 1,000 steps. It may take 1, 2, 3, 4. 4 seconds is not bad. But look at the level of detail here. Isn't that amazing? And that's only on a 200 by 200 plane. If we move this up to the 500, it would look even better. But unfortunately, that would be too slow for this tutorial. Let's look at 200. So again, it's going to take 5, 6, 7, 8 seconds maybe. There we go. Let's go all the way to the end. So I just hit that. So now we're calculating the very last frame. Now, what this is going to show right there is 2.5 trillions. Well, actually, it's almost 4. Look at all those zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then 389. That is pretty amazing zoom. So, and again, you could actually just play this. I'm going to reduce the I'll just change the max steps to 20 just to you see how quickly this zooms in. Eventually we'll not have enough steps to show detail. But so this is how I've animated some pretty cool looking zooms. Now what's neat about this is we're actually talking about a three-dimensional object here. So I could increase my height, say to 40. Now that looks a little weird only because of this. We'll change this to 40. So we have this three-dimensional object. It's pretty cool. So to wrap this up now, I want to show you one more thing, which is how to provide a way to zoom in and center by using a control on the screen. So what I'm going to do is go to the top view, and I'm going to add a rectangle spline, and let's just make it 40 by 40 so we can see it. Actually, I want the width and height to stay the same. I'm going to increase the Y to 40 just so we could see it. All right, so there it is. The reason I raised the height is because it was below the plane and you couldn't see it. So now I would like the width and height to always remain the same. So I'm going to make the width a driver and the height driven. So now if I change the either one, they stay the same. Well, if I change the width, it'll automatically change the height. I can tell that I'm a little slow here. I'm going to enable this, unclick stay enabled so that we can have a quicker interface here. So now I'm going to rename this thing zoom rectangle. And we're going to add some more parameters here. So under user data, we're going to add something called, let's just call it zoom to square. This will be a Boolean. It'll tell us whether the next time we say refresh, it zooms to the square or not. And I'll put that up here in this section. Hit OK. So here it is, zoom to square. So what I want it to do is if this is on and then I hit enable, it will zoom into wherever this is aiming. I'll leave it off for now. So back into our code. Python. Open the editor. So I need this whole new section here. So let's see, this will be after the base scale is calculated. So we're going to say if zoom rect on, then do something. Well, I can't use zoom rect on unless I get the variable in there somehow. So what we're going to do is drag the zoom rectangle into here and expose two things. I guess its width and its position. So it's core, let's see, object, basic properties. Yeah, it's easier to just come over here. Zoom rectangle. All right, so I'm going to grab its width. I want that to be exposed. And its position. I can actually just grab this P, I think. That's position Y. Delete that. Do it this way. Coordinates, position. So I've got width and position. And here I need a couple of new parameters. So we're going to need a float. And we need two floats. No. Actually, float would be width. Position is actually a vector because it's three points. So I'm going to rename this one zoom rect position. And rename this one zoom rect size. Now I'll move this up here. And then the width goes into the size. And the position goes into the position. And then we also created a new parameter called zoom to square. I'm going to put that over here. And so we need a Boolean over here. I think I called it zoom rect on. So that's a Boolean. It's going to be in here. Rename that to zoom rect on. Whoops. I actually accidentally renamed that. I want to rename this port to zoom rect on. All right, so that's all the connections we need. So I can close that, and we'll open this Python editor. Oh, it's already open. All right, so if zoom rect on, well, what do we want to do? Well, we need a new scale. So new scale is going to equal to whatever scale that we calculated just right here above it, times some ratio, the ratio between the rectangle size and the canvas radius. So zoom rect size divided by, Actually has to be the canvas radius times 2, because the zoom rect size is the full width of the rectangle, but the canvas is a radius, so that's only half, so I got to multiply that times 2. So canvas rad times 2. So that gives us a new ratio, and we multiply the scale, so that gives us a new scale. And then we need a new point x, which is going to be, it's going to be the zoom rectangle position x, so the x part of the position, times the scale plus the original. So it's the difference between where the rectangle is and where the center is now, multiplied by that scale. So, and we have something similar for y. So the new py is a zoom position. Remember, it's z, not y. And that's mpy. So down here we use scale and x and y. So what I'm going to do is, I'm going to change this so that we're not using the input px and py. Instead, what I'll do is I'll say up here, px equals mpx and py equals mpz, mpy. So that'll still work even if this zoom rectangle code doesn't run. But if it does, what I'm going to do is modify px and py. All right, so now we've got, I need to set the values we're going to use in that for loop. So the scale we're going to use is actually equal to the new scale. The px we're going to use is equal to new px, and the y is going to be equal to the new py. So that should do it. Now the only other thing we might want to do is update the user interface so that the values that we now have in here are these new ones that we just got. So there's a couple ways of doing that. I'm going to do it this way. I'm going to open up the console, and we're going to see how we can refer to these user data parameters. So we're going to need scale. That's user data 4, mpx, that's 5, mpy is 6, and zoom to square is 14. So what I was doing is dragging these variables over into the console so I could see how I could refer to them. So we need 4, 5, 6, and 14. So, well, these are values from the tag. I'll fix that in a second. So, it was C4D ID user data, comma 4. That equals the, well, I got to convert this back to the base scale. So I got to say new scale divided by base scale. Well, we'll find out if this works in a second. And then uh, 5, 6, and 14. 5 was just the new px. 6 is the new PY, and we want to turn off the zoom to square checkbox. Now, I'm using this value tag here. That is not defined yet. I've got to go back to my I got to add a tag property here. And what it is basically a link to the object. So I'm going to call this tag. Stick it in here, and then I'm going to say object here. So object actually grabs the come on. I'm trying to get these in order here. This always drives me crazy. One more. Oh, come on. There we go. So this tag object, this Xpresso tag, has an object ID. That ID is getting pumped into tag. That's so that I can use it here and access these user data parameters. Okay for that? Well, let's see if this works. Close all these windows. All right, so here we are. I'm going to leave zoom to square off for a second. I'm going to enable that. I'm going to change the steps to, say, 300. So we get a nice... Okay, so that's where we're going to zoom into. Actually, let me start with all the defaults. So we're going to say that's minus 0.75. And that's 0. All right, so we're right in the middle. Now I just have to move that thing around to play with the zoom. Oh, there's one more thing I need to do. Right now, the M scale is being controlled by formula. I'm just going to disconnect that. So it's no longer attached to time. Now it's attached to this position of the rectangle. All right, so here's the zoom rectangle. I'm going to grab it and say move it right there. So we should see what's in this rectangle in this whole plane. Once I click on zoom to square and then enable. Okay, it worked. So let's try zooming in a different spot. How about on this thing? And I can hit the scale here and actually go a lot tighter. Go back here, zoom to square, and enable. Oh, neat. So now go back to zoom in right there. Zoom to square, enable. So there you go. That pretty much wraps it up. The only other thing that might be cool to do is change this icon. So I'm going to click on this. And I'm going to load a JPEG of a Mandelbrot. And not copy that. And so now the icon looks like a little Mandelbrot set. So once you've done that, you can click on it and do a file, save tag preset. I'll just call it Mandelbrot tutorial. And then hit OK. Now we could create a new project. Oh, go back to that one first. I'm going to also want to copy this. So we go back to our new project and create a plane. Make it 222 by 222. Look at the top view. Paste that zoom rectangle and make this editable. And add a tag preset, and we called it Mandelbrot Tutorial. So what I'm not sure happens is the zoom rectangle didn't relink itself. That's subject for another day, but all right, so we could do this fairly easily. So I need to add the position and the width. And the position goes to position, and the width goes to the size. Get rid of this one. Now it should work. All right, so we go to the plane and just, all right, so we're at 0. Let's just enable it. Oh, it when I saved the tag, it had all the presets. Let's just go back to a scale of 1 and enable. And now let's try zooming in. Well, let's say to that little bubble right there. Zoom to square, enable. And bang, there you go. So at this point, one thing you could do is let's move to a spot and zoom to it. And let's just keep zooming in here for a little while. Zoom to square. And we'll do one more zoom to square. So right now, I could tell by my my scale that I'm 0.000002. Let's go again. Zoom to square. Now, you can make this your center point. So save the X and Y. Then go into the tag and reconnect the M scale. So now it'll scale to time instead of using the zoom rectangle. So let's go back to the beginning. Turn on stay enabled. Enable it. And it's going to zoom right into that spot when you play. So you could zoom in as far as you want, and then, like I said, open up that tag and reconnect the time zoom, and you got yourself a cool little animation. I'm just going to jump ahead here, see how far we can get. Seems to be taking a long time once we get up here. Well, anyhow, that is about it. You got yourself a cool way to play around with Mandelbrot Set. Well, thanks for sticking with me through all this, and I hope you picked up a couple of pointers. There's a few things I didn't cover. One is that you could clone cubes onto all of these points, and it would offset the cubes in the same way that the points are offset. And so if you look at that from the top, it would look a lot more like square pixels. Another thing I didn't do is talk about how you could use a plane effector with a Python fall off, and that would give you the same kind of result, but you'd have the ability to add additional effectors and fall offs. But that's a topic for another day. Well, with that, I will say goodbye. Thank you very much for sticking with me through this. I hope you picked up a couple of interesting points. So long until next time. Bye-bye.